So one more time, a standard form is ax plus by equals c. Anything in this form will have an x plus a y equals a number. So we're going to look at some things that are linear and nonlinear. Notice that this is standard form, so it's considered to be linear. This is also standard form because it can be written as a standard form equation. I also know it's linear because there's a y to the first power and an x to the first power. This is linear because it's got a y to the first power and an x to the first power. These are not linear. Things that make them not linear are these x and y being multiplied together. This exponent right here, it's not an exponent of 1. And this part right here where the y is in the denominator. So the next type of problems, what we're going to do is we're going to look at whether or not these form linear equations. So I will do that. This right here is not linear. I know it's not linear because I have an x and y being multiplied together. The next one is linear. I know it's linear because each of these have an exponent of 1. The next one, this one is also linear. Even though there's not an x, there is a y value to the first power. There doesn't have to be an x value. And this last one, because this exponent has a variable in it, it is not linear. So I'm going to review those back here again. It is not linear if you have two variables multiplied together, if you have an exponent other than a 1, or if your denominator has the fraction, or has the variable in the bottom of the fraction. So this next few slides, I want to mention that linear functions are graphs, linear functions whose graphs are not horizontal. The domain and range are all real numbers. Remember, a horizontal line looks like this. So anything that does not have a horizontal line, and it is a linear function, the domain and range is all real numbers. However, there are real-world examples where the domain must be restricted, and we're going to do some examples like that. The reason for that is because we're not going to have a negative number of dogs. We're not going to have a half of a dog or half of a person. So some quantities are going to have things that can't be negative or must be whole numbers. Looking at these examples I have here, the first one says the relationship between human years and dog years is given by the function y equals 7x. We're asked to graph this. I think you guys will find it easiest to just go ahead and make a table. We'll just list some values for our x. Our x values, when we plug 0 in, so I have 7 times 0. 7 times 0 is what y will equal, which is 0. 1 times 7 is 7. And 2 times 7 is 14. Excuse me. So when I graph these, I have the point 0, 0. I have the point 1, 7. And I think what I'll do is count by 4s, or count by 2s here, to make this graph fit on this page. So I have 1, 7, and 2, 14. When I graph this, I am not going to extend this below this line. The reason for that is because we're not going to have negative dog years or negative human years. So its domain, okay, is anything where x, okay, x cannot be negative, so anything where x is greater than or equal to 0. The range is the y part, so where y is greater than or equal to 0. My last example, it says at a salon, Sue can rent a station for $10 per day plus $3 per manicure. The amount she would pay each day is given by this function. I probably will not get this graph, so I will do that in class. The function would be f of x equals, it's $10 per day plus $3 per manicure. Why don't you figure that out and then we'll talk about that in class.